Hi, welcome to my Twitch stream. My name is Andrew Turley. It is February 1st, 2019. And the plan for today is FFI and Pony. I guess, yeah, can anyone hear me? Well, we'll see how this goes. Yeah, so FFI and Pony is the foreign function interface, and it lets you call C functions from Pony. This can be useful for taking existing libraries and wrapping them up and calling them from Pony. It can also let you implement things in Pony that you might not otherwise need things to work. So let's see if my bot can connect. Okay, well, I'm going to keep going and we'll see how this works. Anyway, so there is a section of the tutorial, tutorial.pony link, what's available. So at a high level, you can call C functions and you can pass basic types around from your Pony code into your C code and back from your C code. So, there's also a way to define structures so that as long as the structure that you've defined in Pony matches the structures that C is working with, then you can pass those structures back and forth. So let's kind of start with some basics here. So that we would call it from Pony. Bear with me for a second, I'm a little rusty at this, but okay, so we're going to create a function called mine. Hello. And so should be able to compile this. Okay, and then should be able to turn this into a library. Okay, and then we're going to create a pony program that calls into this function. Okay, so the first thing we're going to do is going to tell it to use this library called mine. And we're going to tell it to call mine the function that we've called mine. So this thing in the brackets is the return type for the function. So we can specify that here, and that will let Pony know that there's no return value. Okay, and now we should be able to build this. Let's see here. A little rusty here, bear with me. I think I may need to tell it the path to search to find that library. There we go. Okay. So I'd forgotten that by default, the current directory is not in the search path for finding libraries. So I've got this pony FFI stream executable now. I run it, it prints hello. It seems like whenever I talk, I run into network errors. Maybe I just shouldn't talk. Anyway. If you're not seeing anything, just let me know. All right. So we've got ourselves a program that calls into a C function that we've written. So that's pretty cool. So let's take a look at something a little more interesting. Let's say that we want to pass an integer in here. to print it out. So as I said, with basic data types like numbers and things like that, Pony uses the same representation as C does. So you don't have to do any wrapping or unwrapping or anything like that. You should just be able to directly pass an integer value. So we should be able to rebuild, create our library. Oops. Rebuild our program and run it. And now we get hello 42. Okay, I think I'm back. I guess we'll see if this works. Okay. Sorry about that. Thanks for everybody's patience here. Don't know what's going wrong. Looks like things have started to go wrong again. I'll keep at this for a little longer, and if it doesn't work, then maybe we can just reschedule this when my internet goes back to working. Anyway. Great. So yeah, we just did a little program that takes an integer from Pony and prints it out. So let's keep going with this. We'll return an integer, so we'll just take x and we'll multiply it by 2. So coming back over to the Pony program, we're now going to tell it that this function returns an I32. So I'm going to do this. So that ret is going to be an I32, and then we should be able to do out print ret string. Great. So we'll come back over here again. We'll compile with Clang, create our archive, run Pony C. And there we go. We were able to get a value back, and we were able to print it out. So nothing really super exciting here so far. What we're doing is just, passing very simple data types back and forth. So that's kind of the beginning of what you would want to do with FFI. So we can save ourselves a little bit of time, or typing, I guess, by up at the top saying, giving a little information about mine. So this will tell it the parameter types and return type for mine, so that we don't have to include that down here when we call mine. So since we didn't change the C code, all we need to do is recompile the Pony part. Oh, sorry. And this needs a parameter name. It doesn't actually matter what you put as the parameter name. You just have to put a parameter name in there. Okay, so again, what that means is that we no longer have to tell it what the return type for mine is at the call site. You can just define that up here. So, yeah, so far so basic. So we can start doing some slightly more interesting things. Let's create another function that returns a string. And let's get this working, and then we'll go over what's happening here. But the basics are that we're telling it there's a thing called getString that returns some sort of raw pointer. So let's just get this for now, and then we can start getting a little fancier with it. So with all calls to C functions, we have to put an at the beginning. That's how Pony knows that we're dealing with a C function. So compile the C again. Build everything. No crashes, that's great, right? Okay, so we got this pointer back to the C string, and that's a neat parlor trick, but you're probably wondering, okay, well, what can we do with that? Well, let's start poking around a little bit. Let's go into the Pony compiler here. Get out of my weird branch. And let's take a look at what we get in the standard library to deal with strings. So let's take a look at string.pony. So string.pony has a few different constructor methods. So the string is the class that we use for strings, and the standard one that usually gets used is this create, which creates a string with ref capability. But there's a few other things that we can do. So we can create a string from an array. And this is a Pony array, so if you give it an array val, it will create a string. You can also create a string from an ISO array. That'll give you back an ISO string. And then there's a few options for creating a string from a C string pointer. So this one from C pointer looks promising, but what we need to understand is that there's a caveat here. This must be done only with C FFI functions that return Pony alloced character arrays. So Pony has its own allocator, and that allocator knows how to play nice with the garbage collector. And so if you create a Pony string from one of these Pony alloced arrays, then everything will work nicely, and things will get garbage collected, etc. But if your string is not pony alloced, if it's created with a regular allocator, or it's a constant or something like that, then things won't work well. And I think you'll just end up with a memory leak, just depending on how many strings you're processing. That may be a just, or it may be a, oh boy, that's a bad thing. Either way, not good. So then there's this from C string. This returns a string from a pointer to a null terminated C string without making a copy. So in this case, the string must be null terminated. But this has the same caveat. Only with C FFI functions that return pony alloc character arrays. Then you've got your copy C pointer, which creates a string by copying a fixed number of bytes from a pointer. So this is getting to the point where it's a little more useful. This will take the C array that was allocated however it is that C wanted to allocate it, and copies that array into an array that's used by pony. You have to give it a length, so this is safe to the extent that you know the length ahead of time. And then if you're feeling like gambling, there's copy string. So for now, this is probably what we want. What this does is it takes a pointer and it copies the null terminated string there. So note the scan is unbounded. If there's no null terminator, then it'll just kind of keep reading until it hits 0. So not the best thing. Okay, so it takes a pointer U8, so we're going to change the declaration here and say pointer U8. Pony is a little non-specific on how you want to treat pointers. You've got a fair amount of flexibility. Once you start using the FFI, you kind of throw out a lot of the safety that Pony tries to provide out of the box. So for things like pointers, you can get a pointer back, and as long as the function that you're passing that pointer off to later takes the type that you've said it is, then the Pony compiler won't complain, and it should more or less work correctly. So this is a little more of a notational convenience, picking types here. Anyway, we get a pointer back. It's a pointer U8, and so we're now going to create a string from copy C string. Of pointer. And then we're just going to print that out. So again, we didn't really change anything in the C code, so we don't have to compile any of that. We just build the Pony program. And there we go. There's our string. Okay, so far, pretty normal. All right, so let's take a look at something maybe a little more interesting. let's, okay, so can we treat pointer none as void? Are types being checked in any way during linking? No, at the linking stage, there's really no checks. So the only reason that we had to change the pointer type was that copy cstring expects a pointer U8, and so we wouldn't have been able to pass it if into here if we had kept it as a pointer none. If you're writing your own libraries and you're passing things back and forth from your own C code, you can kind of do whatever you want. So Pony gives you a little bit of ability to check to try to make sure you're doing the right thing, that you're passing the right things around, but it's not really super strongly enforced. You're kind of expected to just be on your best behavior here. So again, Pony tries to make a lot of guarantees. Once you start using the FFI, most of those guarantees just get thrown out the window. So you suddenly open yourself up to a lot of places where you can shoot yourself in the foot. So let's create a structure, and let's kind of take a look at how structs work in Pony. And let's also see if I can remember how to make structs work. Is that going to compile? You folks in the audience are probably on a delay, so there's only so much you can really see. Something unfortunate happened, and now I don't have my chat window showing up here. It's too bad. Kind of like that. Oh well, okay. So chat's not showing up in the stream, so if I ever stick this up on YouTube, nobody will know what the chat messages were. Sorry, YouTube people. All right, anyway, back to what I was doing. I created a struct. Let's just see if I'm remembering C well enough to actually have created a struct. Yay, it compiled. So, okay. All right, how about now? Have I screwed anything up? Again, I'm kind of rusty. Let's see here. Yeah, I'm missing a star on my X. Thank you, Brian. Brian has always got my back. Oh. Sure. gonna make me do things like this. I need to include the standard library header. Okay. Cool. So that built. Basically, I just wanted to build it to make sure I wasn't totally screwing up my C here. So let's create that archive again. And now, to be able to use this in Pony, we need to say struct, just calling this thing ms, feel a little better here on this side. So I'm creating the struct, and so I should be able to, and let's say, let's come back here to the Pony tutorial. Calling C from Pony. Yeah, Brian, needs to be a pointer to my struct. That's what I was trying to remember was what was required here. Okay, so a maybe pointer will basically give me a way of saying this thing is either a pointer to this thing or it's a pointer to null. So I can call the apply method and it will give me back a pointer. So basically I can say try and this should print out the value of x, which should be 20. Otherwise, it will raise an error. And if we get an error, then let's just say we had an error accessing MS. Okay, so let's go back to building everything. Build the object file, build the library, build the Pony program. What did I do wrong here? Oh. My struct. Okay, yeah, sorry. It's saying unexpected token X after type, interface, trait, primitive, class, or actor definition. And you could probably argue that this should say or struct, but let's not quibble. So we should be able to say let here. Oh. Let me do this. Okay. So it needs a default value. And now we should be able to run our program. And look at that. We got 20 here at the end. So that's how you start to use the FFI to work with structs. And I think for things like, for basic values like I32s, I don't think we need to do this, but I think you can also embed these things. And so the way it works is that if you had basically if you had let and then some other type here that wasn't like one of the basic types like I32 or something like that, it would actually include a pointer, or it would expect this thing to be a pointer to that type. And so if you have like structs within other structs, you can use the embed keyword. I think we should be able to do this here, and it shouldn't make any difference because, again, basic values doesn't matter. Oh, okay, embed fields must be classes or structs, so I guess it won't let me do it with just the I32. So. Side question. Is FFI aware of different byte lengths of types on different architectures, like long, long, X? If not, any hints on how to handle that when wrapping some C libraries? No, that's where you start to get into some architecture dependent stuff. And so all of the, for example, all of the numeric types in Pony have a specific number of bytes. You have I32s and I34s. Your Pony code is going to need to take into account the architecture of the C code that it's running on. There's not really a good way around that. So yeah, sometimes your code will end up being a little, it can be architecture dependent depending on how complicated some of these things get. Sorry, I wish I had better advice there. Okay, so rebuild this, make sure we're in a good place. Okay, so let's just kind of review what we've seen here. We've passed a basic type in to C function and gotten a result out. We've played around with getting string values out. You can also pass string values into Pony functions. So let's take a look at string again. So string has this has these two functions, C pointer and C string. C pointer returns a C compatible pointer to the underlying string allocation. C string returns a C compatible pointer to a null terminated version of the string, safe to pass to an FFI function that does not accept size arguments, expecting a null terminator. So you can use these two functions to get an underlying C string representation of a string, and then pass that off to a C function. So that's kind of useful if you want to work with C strings. And if you don't want to work with C strings, then you probably won't ever want that. Let's take a look at arrays real quickly here. So arrays let you do some things that are similar to what you could do with strings. There's a from C pointer and C pointer argument. So, or sorry, not argument, function. So from C pointer lets you pass a C pointer to the array, and it will it'll create a new array from that C pointer. As it says, the contents are not copied, so it's up to you, the programmer, to figure out how you want to handle that. And then there's C pointer, which returns the underlying C style pointer. So if you want to use these functions, you're going to have to probably do some memory copying on your own to get it to work. It's not too terribly difficult. You should just kind of be aware of that. Again, the important thing when you're passing things back and forth between C is that if you have anything more complicated than one of the basic types, you want to make sure that you know where things are being allocated and how they're being allocated and deallocated and who's responsible for all of that. If you've ever done any FFI programming, this is kind of the same sort of thing you'd have to deal with in just about any other language. So hopefully that doesn't come as too much of a surprise to people. Pony gives you some ways of dealing with FFI, but or with C functions, but you still have to do some work to get it to work correctly. So I'll just talk a little bit about a few things. Pony doesn't really have any ways to easily take something that was defined in C and turn it into an equivalent Pony declaration. So for example, we had to create this struct on our own, even though the struct was defined in a C file. Or, if we had been doing this properly, we probably would have defined it in a header file. Pony doesn't have any way of, parsing that header file or doing anything to discover what the shape of that struct is. So you're kind of on your own. You have to put that together yourself. Pony does not support enums, so you can't look at, you can't basically grab a list of enums from a header file and use that in your Pony program. You're going to have to figure out some way within your Pony program to define the enums in some way yourself. If you want to see an example of that, we can look in packages, process, it's in process monitor. Oh, maybe it's signal. That's it. So yeah, in the signal package, we've got this primitive called sig, and then we've got functions on the primitive for the various types of signals that we might want. And this will return the value for those things. So that's basically how you would handle something like an enum. And, if you say, well, that's awfully verbose, well, that's the way it is. I don't have a lot of good things to say. I don't have a lot more to say to help you out there, other than to say, if you have some ideas, you can hit up the Slack channel or the IRC channel at the mailing list. If you want to create an RFC for something because you think you've got a really good way of handling this, by all means, please do that. I don't want this to sound like I'm telling you to go take a hike or anything. Just letting you know that without creating your own tools here, you're kind of on your own to figure out how you want to do that. Make sure that whatever you're using for your enums matches whatever's being used on the architecture that you're running on. Yeah. So the signal library is a place where you can look to see how some of this is done. You can also look at the regular expression library if you want to see if you want to see an example of some FFI. The regular expression library is a wrapper around the regex package. The PCRE2 package. That's what I meant. And so if you come in here, again, you'll see some of these, what would normally be something like a global variable, or a define, is set up here in a primitive, and these values are copied in from the header file for the library. So in addition to enums, there's also no good way of automatically pulling in defines. You're going to have to look at the header file, copy those things over yourself, and keep an eye on them. If they change, you need to change them in your Pony program so that things are compatible on both sides. But yeah, this library is actually a pretty good place to look if you want to see some FFI in action, because there's a lot of calls into this library from Pony and a lot of extraction of the different pieces of interest here. So one thing I didn't talk about is this address of. So you can use this to get a pointer to a to a value from Pony and pass that off into C. You can only use address of in the context of making an FFI call. So you can't just in regular Pony code say address of. You can only do it from within an FFI call. And that's because Pony wants to be safe. So the only thing it'll let you do with an address is basically dump it into C for C to use. But that is nice for doing things like, handing pointers to things around to your C code. I haven't talked about it. There's also a way to pass function pointers to create functions in Pony that can be passed off to C as callbacks. I haven't really used that a whole lot. It's in this callbacks section. So maybe next time I will spend a bit of time kind of going over this and talking a little bit about how to do the callbacks. But hopefully this has been a good, somewhat informative introduction to FFI. If not, I apologize. Sorry about the technical difficulties at the beginning. Thank you for your patience on that. Yeah, that's kind of the long and the short of it. Thank you all for tuning in here. I think I'm going to end the stream now, but keep an eye out. Next week I'll be doing some more streams. Thanks, y'all. Take care.